Now we discuss 555 timer. Timer is a circuit which produces time delays. In this lecture, we will see the 555 timer. What is inside a 555 timer? Different types of 555 timer circuits. And here we concentrate basically on the astable mode of operation of a timer. Astable mode of operation of a timer circuit. A timer is a most popular and versatile integrated circuit. It is 30 years old and still being used. It is the combination of digital and analog circuit. It is known as a time machine and it performs a wide variety of timing tasks. Here are the few applications of the timer circuit. Just like switches, cascade timers, frequency dividers, voltage controlled oscillators, and pulse generators, and LED flashers. Here on the top right corner we can find the IC diagram, pin diagram of a timer, where first one is the ground, second one is the trigger, third one is output, fourth pin is reset, fifth pin is control voltage, sixth pin is threshold, seventh pin is discharge, and eighth pin is VCC. Internal circuit and a bit deep into a 555 timer will give you the internal circuit diagram present over here, and generally we use the timer in the form of an IC. Next, the internal diagram of a 555 timer. The name 555 is due to the three resistors which is having a values of 5k, 5k and 5k. Here you can see the three resistor, one is 5 kilo ohms, this will be 5 kilo ohms, and this will be 5 kilo ohms. Here we have two operational amplifiers which are used as the bottom one as the lower comparator and the top one as the upper comparator, and we have a flip-flop called as a control flip-flop. Basically here we use an RS flip-flop, and output of the RS flip-flop Q is connected as the output of the timer. Basically here the circuits involved is the operational amplifiers connected as upper comparator and lower comparator, and here you can see the inverting terminal of the upper comparator is connected between these two resistors, and the non-inverting terminal is connected between these two resistances, and here the transistor which works as a switch will support in discharge of the capacitor what we connect here whenever we operate that in the modes. Basically we operate this 555 timer in two modes. One is monostable multivibrator using 555 timer, and another one is astable multivibrator using 555 timer. As we have seen this already, the voltage divider has three equal 5 kilo ohm resistor. It divides the input voltage VCC into three equal parts. The two comparators are op amps that are used to compare the voltages at their inputs and saturate depending upon the value of the input. That is, the op amp will act as a comparator, that is, it will be in open loop. Output will be at plus saturation or minus saturation, where the output provided by this comparator is treated as the input. That is, plus Vsat can be treated as 1 and minus Vsat can be treated as 0 here, so that proper input signal or proper input combinations can be applied to the control flip-flop. These are the flip-flop, how we take the values. This gives about the transistor and the necessity of the transistor which will be used for discharge already discussed. Now if we connect an operational amplifier, a 555 timer as an astable multivibrator, the circuit diagram will be like this, and if it is connected in a monostable multivibrator, the circuit diagram will be like this. Today we will discuss the astable multivibrator. The astable multivibrator circuit is this. When we apply VCC, here we are discussing the operation of the astable multivibrator or astable pulse train generator. When the VCC is applied, then the capacitor will start charging in this direction, taking R1, R2, and capacitor will start charging. When the capacitor starts charging, it will start from 0 to VCC value. In the process of charging of the capacitor from 0 to VCC, whenever it reaches a value of 2/3 value of VCC, that is 2/3 into the value of VCC applied, then the voltage present here will switch the comparator. One of the comparator will be switched. Then the output of this control flip-flop will be changed. Example, the output is taken as 0 initially, then when the capacitor charges to 2/3 value of VCC, then the output of the control flip-flop will make the output equal or will change the output value. And when it reaches in the process of charging from 0 to 2/3 value of VCC, then when it changes, one of the comparator present here will changes its state and changes the input conditions to the flip-flop. Then the output will be switched. At that time, after 2/3 value of VCC, then the capacitor choose this particular path. The path is C R2, and then it will start discharging through this path. That is, charging of the capacitor takes place from VCC, R1, R2 and C. That is, charging path involves R1, R2 and C, and the discharging path will involve C and R2 in this form. This will keep on continuing because the threshold values of this upper comparator and lower comparator will keep on will be changing due to the change in the values of the voltages present in this particular capacitor. Then the output will be switched from one stage to another stage. So the output here we can see the value present here will be 1/3 VCC and the value present here will be 2/3 value of VCC. This curve shows the charging and discharging of a capacitor, and this will show you the output pulses. What is the uses of astable multivibrator is? It is used for flashing LEDs, pulse width modulations, pulse position modulations and periodic timers. This is one way of representing. Another way of representing the timer as charging time, and charging time T1 is given by 0.69 R3 into R1 plus R2 into C1, and similarly the discharge time is given by 0.693 into R2 into C1, and the total frequency for calculation of time can be given by 1.44 divided by R1 plus 2 into R2 into C1. So this is a picture for animation of this particular operation of the 555 timer as an astable multivibrator. Thank you.